Hey everybody, welcome back to another AP Precalculus video. Today we're going to be going over 1.8 rational functions and zeros.
Alright guys, so these are our learning objectives. We will be determining the zeros of rational functions and using those zeros to find when the function is increasing or decreasing, or when it's positive or negative.
Okay, so today we're going to be finding zeros of a rational function. So the zeros of a function are the input values that yield an output value of 0. So in other words, these are the points of the graph that touch the x-axis, where the y value is 0. And in a rational function, the numerator has to be equal to 0 to guarantee an output of 0, because 0 divided by anything but 0 is going to be 0. So we can calculate this by factoring the polynomials in the numerator and the denominator. And we can ignore factors that are present in both because they just cancel out. And then we can find the zeros of the remaining factors in the numerator.
All right, so now we're going to be looking at an example of finding zeros of a rational function. So this is just going to be based off the last slide, and we're going to be following those 3 steps. So right here, we're given the rational function g of x, and we have to find the zeros. So g of x equals x squared plus 3x minus 10 over x squared minus x minus 30. So our first step is to factor out both the denominator and the numerator. So we're just going to look at the denominator and the numerator and act like they're 2 independent polynomials, and we're going to factor them out this way. So this polynomial right here, x squared plus 3x minus 10, when you factor it out, you're going to get x plus 2 times x minus 5. And then in the denominator, x squared minus x minus 30 is going to be x plus 6 times x minus 5. So our first step is just getting those factors in our numerator and our denominator. Next, we're going to be looking at our second step, which is ignoring the factors that are present in both the numerator and the denominator. They're going to cancel out. And in later units, you're actually going to realize that when factors are present in both the numerator and the denominator, that actually means that at that input value, you're going to be getting a hole in your graph. So we're going to be talking more on that in later units, but for now, if we're just finding zeros, we can ignore that. All right, so since x minus 5 is present in both the denominator and the numerator, we're just going to scratch those out for now. And then our third step is finding the zeros of the remaining factors in the numerator. We're only going to be looking at the numerator here, and since our remaining factor is x plus 2, that means we're going to be having a 0 at x minus 2. So our zeros of g of x are going to be x minus 2.
Okay, so now we're going to talk about positive and negative intervals and interval notation. So when we do interval notation, we be really careful with brackets and parentheses. So brackets indicate that an input of an interval is included within the interval, and that would be a greater than equal to or greater than and less to. So that includes the sides of the numbers that we're mentioning. Parentheses are different in that they don't include those numbers. So they're the input of an interval that is not included within the interval. So we use this for the infinity and negative infinity and input values where the sides that we're referencing are not included. So if we did like 6 to 8 and we did parentheses, then 6 and 8 wouldn't be included. But if we did brackets, then 6 and 8 would be included. And intervals are always written from the left side of the graph to the right side of the graph. So we go from the negative side to the positive side.
All right, guys, so this is our first example, and we'll be finding when f of x is equal to 0, when f of x is greater than 0, and when f of x is less than and equal to 0. Okay, you guys can pause real quick and do it yourself. So f of x is equal to 0 at -2 and 0 because that's when f of x crosses the x-axis. F of x is greater than 0 when f of x is above the x-axis. So we see from -infinity to -2, f of x is greater than 0. And we're using soft brackets on -infinity because it's approaching infinity, and -2 since the zeros are not included in f of x is greater than 0. Also, -1 to 0 because it's above the x-axis, and -1 isn't included, or we use soft brackets because that's a vertical asymptote and we're approaching -1, but we never actually touch it. And from 1 to infinity, because that's when f of x is also above the x-axis. And since there's a horizontal asymptote at 1, it never reaches the x-axis, so it's never negative. So f of x is less than and equal to 0 from -2 to -1. And -2 is included since that's a 0. And then it's also from 0 to 1, since at those points it's below the x-axis. And 0 is included because 0 is a 0 of the function. So next we'll be talking about inequalities of rational functions. So here we have r of x, which is a rational function of f of x over g of x. And our first step is to identify when the numerator and the denominator is equal to 0. So we have to find when f of x is equal to 0 and g of x is equal to 0. Then we have to create a number line and mark those x values on our number line. Then we have to pick a random value between those numbers on our number line to see if the function is positive or negative at that value. And then we have to state the intervals when r of x is equal to 0, greater than 0, or less than 0. And if this is really confusing, we will be going over a few examples so it's easier to understand.
All right, so we're going to be breaking down this example one by one, going through our steps. So our question is find the intervals in which the inequality is true. So we're given an inequality, and then we're given our rational function m of x. We're going to be finding the intervals in which m of x is less than or equal to 0. So you can also think of it as 0 or negative. And then m of x is equal to x squared plus 4x plus 3 over 4x plus 5. So our first step is going to be identify when the numerator and the denominator of the rational function equals to 0. It helps to look at them independently. So we're going to factor out x squared plus 4x plus 3. That's our numerator. And when we factor them out, our zeros are going to be -1 and -3. And then in our denominator, 4x plus 5, well, we don't really need to do factoring on this one. You're just going to solve for x when it's 0, and then you're going to be getting -5 over 4. So we're going to be, and then for our denominator, we're going to be solving for x when it's equal to 0. So our 0 is going to be -5 over 4. And since it's a 0 in the denominator, that also tells us it's going to be a vertical asymptote at x equals -5 over 4. But we're going to talk about vertical asymptotes in later lessons. So just something to keep in mind. All right, so now that we got our values, we're going to be placing them on the number line. That's step 2. So we have -3, -1 from the numerator, and then -5 over 4 from the denominator. And since our denominator's 0 was -5 over 4, we're going to be putting an open circle because it's going to be a vertical asymptote and you can't divide anything by 0. It's going to be undefined. All right, so our third step is we're going to be picking values in between each of our intervals on our number line, and we're going to be testing them out to see if m of x is negative or positive. So right here, we're testing -3.1 because that's between negative infinity and -3. -2.1, that's between these two values, -1.1, and then 0. All right, so once you calculate it all, you're going to be getting positive value over a negative value. So something to kind of save time on tests is you don't really need to know the values, just know if it's positive or negative. That's the most important part. So you're going to be getting a negative over a negative over a positive, and then a positive over a positive, which also means that you're going to be negative over here, positive in between these two values, negative in between -5 over 4 and -1, and then positive from -1 to positive infinity. And then our last step is to just state these intervals. So we're going to be looking back at our inequality, and since we're looking at the intervals in which m of x is less than or equal to 0, we're going to be looking at the intervals in which m of x is negative. So that would be from -infinity to -3, and -5 over 4 to -1. And we're going to be using these brackets because at -3 and -1, m of x is 0.
Okay, so now we're going to look at an example of finding the zeros of a function. So if you want to, you can take some time and pause the video to try to do the example yourself. So How we do this question is that we can factor both the numerator and the denominator, and then we can cancel out the parts that are the same. So in this case, x plus 2 and x plus 2 are both on the top and the bottom. So we can get rid of those. Then, because we're trying to find the 0, we can find what value of x in the numerator will make the numerator 0. And in that case, that value is 7. So x equals 7 is a 0.
Our second example is going to be looking at zeros on a graph and then positive and negative intervals. Right here we have g of x, and we want to know the intervals in which g of x is greater than 0. So that means when g of x is above the x-axis. And we're not including 0, so keep in mind that when our graph touches this x-axis, we are including those points in our interval. All right, so let's look at when the graph is above the x-axis. So we can see from -1, we're above. And then right here, we touch 0 again. So this is a 0 of g of x. This is when g of x is 0, and then we're still above. All right, so since we're not including the points in which g of x is equal to 0, there's no equal sign right here, we're going to be including everything except these zeros that are above the x-axis. So from -1 to 0, and again, not including these points, we are above. And then from 0 to positive infinity, our input values are increasing continuously. And again, not including the 0. So our interval is going to be -1 to 0, and 0 to infinity. All right, and then now we're going to be looking at when g of x is less than or equal to 0. So this is the opposite. We're going to be looking at when our output values are negative or when our graph is below the x-axis. And this time we are going to be including those points in which g of x touches the x-axis, are zeros. So we can see that below we're going downwards, so negative infinity, and then right here it touches the graph at -1 before crossing. So from negative infinity to -1, our graph is negative, and again, including that 0, so a hard bracket for -1. All right, and then we're just going to be looking for those zeros. So when our graph touches the x-axis, so -1 and 0.
All right, guys, so this is our last example, and we're going to find when p of x is greater than and equal to 0. So p of x is equal to x squared minus 5 over x squared plus 10x plus 25. So our first step is to find when the numerator is 0 and when the denominator is 0. So to find when the numerator is 0, we have to set x squared minus 5 equal to 0. So then we get x squared is equal to 5. And we solve for that, and we get the square root of 5 and the negative square root of 5. And for the denominator, we do the same thing, and we set the denominator equal to 0. And for this one, we can factor, so we get x plus 5 times x plus 5. And we find that x is equal to -5. So that's our first step. And now we're going to place these values on a number line. And we put an open circle at -5 because that's when the denominator is equal to 0. And as we said before, you cannot divide by 0 because that would make the function undefined. So now we have to test our values to figure out what portion of this number line is positive or negative. So if we plug in a -6 over here, we will get a positive over a positive. So that's the entire thing here is positive. If we plug in a -3 between these two numbers, we'll also get a positive over a positive, which is just positive. If we plug in 0 between these two numbers, we'll get a negative over a positive. So that would be negative. And then if we plug in 3 over here, we would get a positive over a positive. So that's just positive. Okay, so now since we found when the function is positive or negative, we can solve our question. So from negative infinity to -5, p of x is positive. From -5 to -√5, p of x is positive, and we include -√5 because that is a 0 of p of x. And finally, from root 5 to infinity, and we include root 5, we use the hard brackets because that is a 0 of p of x.
That's all for 1.8 rational functions and zeros.
Thank you guys so much for watching, and stay tuned for more AP Precalculus math lessons and practice.
Bye!